Boiler and its auxiliaries. Boiler, otherwise called as steam generator, supplies high-pressure superheated steam to turbine. Water and steam cycle. Boiler feed pump supplies feed water to boiler through high-pressure heaters with sufficient pressure and temperature. The feed water flow is regulated by pneumatically operated automatic control valves. Then the feed water goes to economizer, which improves the boiler efficiency by extracting heat from exit flue gas and thereby increases the feed water temperature. The water heated in economizer is sent to boiler drum, which is located at the top of the boiler structure. Then the water from drum flows through downcombers to bottom header of furnace water valve. The furnace water valves are membrane type, which absorbs heat from the furnace. The steam water mixture formed in water valve rises up naturally and enters to drum through riser tubes. Steam and water is separated in drum, where the water goes down to downcomber again, and saturated steam goes to superheaters. Required safety valves have been provided in boilers to safeguard the vessel during abnormal pressure rise. The saturated steam passes through 3 stages of superheaters and picks up more heat from flue gas to become superheated steam. The superheated steam is carried by main steam line to the turbine. Steam temperature control. Desuperheating spray system has been provided for maintaining required steam temperature. Cleaning devices. The superheater, reheater and economizer coils are cleaned by long retractable steam soot blower periodically. The furnace is cleaned by online water jet lancer periodically. Auxiliary steam system. Auxiliary steam system has been provided for meeting steam requirement of various auxiliaries of power plant. The steam is tapped from main steam line or cold reheat line. Then the temperature and pressure is reduced and supplied to the various auxiliaries. Firing system. Tangential suspension firing system is adopted in these boilers. The lignite stored in the boiler bunkers are transported to belt conveyor by plate belt feeder. The lignite quantity can be varied by adjusting variable frequency drive motors. The conveyor belt carries the lignite to resuction duct, in which flue gas is sucked from the furnace in order to dry the lignite. Then the lignite is pulverized in the beater wheel mill and carried to the lignite burner by the centrifugal action of beater wheel. The combustion air taken from windbox is thoroughly mixed with the pulverized fuel and admitted into the furnace through lignite burners, and complete combustion takes place in the furnace. Draft system. Balanced draft system is adopted in the boiler. The forced draft fan of axial flow, variable blade pitch control type sucks air from atmosphere and supplies for combustion. The steam coil air preheater is placed at the outlet of FD fan to increase the air temperature during initial light up of boiler. The steam taken from auxiliary steam header will be used for heating the air passing through steam coil air preheater. The induced draft fan sucks hot flue gas from furnace through regenerative air preheater and electrostatic precipitator, then lets out the same to atmosphere through chimney. The induced draft fans are also axial flow variable blade pitch control type. Regenerative air preheater. In the bisector type, regenerative air preheater, flue gas goes out from furnace through one half. Through the other half, air from forced draught fan comes into the furnace. The air preheater rotates at slow speed, that is 2 rpm, by means of an electric motor. The heat contained in hot flue gas is transferred to the incoming air, thereby increasing the air temperature, and the flue gas temperature is reduced. This helps to increase the boiler efficiency. Electrostatic precipitator. Electrostatic precipitator removes the fly ash from the flue gas so that the suspended particulate matters in stack outlet is maintained within acceptable level. Chimney. The dust-free flue gas is discharged to atmosphere by ID fan through chimney. The height of the chimney helps proper dispersion of flue gas into atmosphere, thereby reduces ground level concentration of pollutants. Circulating fluidized bed combustion. Circulating fluidized bed combustion. The firing system of these boilers differ from the pulverized fuel firing boiler. The lignite, which is less than 10 mm size, is fed into the combustor directly. Nearly 550 tons of bed material of size ranging from 0.2 mm to 1 mm size is already charged in the combustor. The primary air supplied through number of nozzles provided at the bottom of the combustor fluidizes the lignite along with bed material. Required secondary air is supplied to the combustor to ensure complete combustion. The hot bed material circulates internally in the combustor and dissipates heat to the surrounding water walls. Some portion of the fine bed material goes out of the combustor and returned back through recirculating cyclone. The bed material from the cyclone can also be diverted to bed heat exchangers, where the heat is transferred to part of reheater and superheater placed there. The hot flue gas goes out of the combustor, passes through the second pass, where it transfers heat to superheater, reheater and economizer. Then passes through air preheater, electrostatic precipitator and goes into the atmosphere through chimney. The fly ash collected in electrostatic precipitator is disposed of by dry ash collection system. The bottom ash is collected and cooled in ash coolers, which are placed at the bottom of the combustor, and then it is transported to bottom ash silo by conveyor belt for disposal. Advantages of circulating fluidized bed combustion. The combust temperature is maintained less than 860 degrees Celsius, hence nitrous oxide emission is minimized. Lime is added to the combustor for capturing sulfur oxide. Thus, sulfur oxide emission is also minimized. Hence, it is eco-friendly boiler. The circulating fluidized bed combustion boilers at TPS2 expansion is of new technology. This is the first of its kind in India for 250 megawatt units. These boilers are more efficient and eco-friendly.